Hello and welcome to Lesson 5, Learning to Program with Python. So it's a beautiful day outside today, and we're going to stay inside and we're going to learn all about lists and how to manipulate them in the Python programming language. So lists, sometimes called arrays, are an interesting data structure because they're different from what we've looked at before. So far, we've used variables to store data, but each variable only stores one piece of data. But sometimes we want to store a whole series of items in one variable. And to do this, we use arrays/lists. So before I continue, just a little note. On your GCSE exam syllabus, it will talk about arrays. However, Python doesn't really have arrays, it just has what we call lists. But a Python list, we're just going to use like an array. You don't have to worry about the exact differences. Programming languages usually have an array and a list type. Arrays are simpler, lists are more complicated. Python pretty much does away with the simpler array type and just has the more advanced list type. But we don't have to worry about that. We're just going to use lists as if they're arrays to make sure you've got all the information you need for your exam. So an array is just a collection of something. So for example, a collection of integers. In Python, we can have mixed data types if we want, because Python uses lists which are more powerful, more complicated. But we're just going to generally have single data types in our lists so that we can treat them like they're the simpler array type, because that's what you're going to get in your exam. So let's look at an example. You can type this out, try it, run it, see how it works as we go through it. So we've got our variable x, and we're going to say x equals, and here we go, we've got 3596. We're going to store 4 values in one variable. So make sure you're using the correct syntax. We have to put the list of items in the square brackets, and we separate each item in our list using commas. And then we've got some print statements. We're going to print different data from our list. We're going to say print x, print 0, print 1, print 2, print 3. When you run the first line, print x, it will quite literally print 3596 in square brackets on screen. So it'll say print the entire array with the square brackets, with the commas, everything together. Usually that's not what we want to do unless we're just wanting to check the contents just when we're debugging our program. We'll look at better ways to do that as we go through the series of lessons. When we say print x0, what's going to happen? Well, it's going to print out 3. Can you work out why? Well, when we give a number here, like 0, 1, 2, 3, that's saying what the index position in the list is that we want to print. And it starts at 0 because computers normally start counting at 0, not 1. So if we have a look here at this list, we see look at the index position of the elements in our list. This is position 0, this is position 1, 2, 3. So there are 4 items in the list, and that's 0, 1, 2, and 3. So if we say print x0, it goes and prints out the 3. When we say print x1, it's going to print 5, print x2 is 9, and print x3 will print out 6. So that's how we can access each individual item in our list/array. So when we do that, again, we have the name here, and then we have the position in the square brackets. So make sure you use square brackets, otherwise you're going to have a problem. You're going to start crashing and having errors. Key point here, when we're programming, when we're creating our lists, our arrays, we're always going to start with position 0. The first item is position 0, not position 1. Okay, That's just how computers like to count. So as well as printing out numbers, we can also have lists and arrays that are full of text and other data types. Have a look at the following program. What's going to happen? Well, again, see, we're creating our array, our list, because we're using the square brackets. Again, we're separating each item by using commas. And because we're putting in text, don't forget your inverted commas, your speech marks around the items. When we run it, we say print name 3. Well, remember, we've got 0, 1, 2, 3. So the first time we run it, it's going to print the name Chie. And then the second print statement is going to not print Bob, because that's position 0. It's going to print Rita. That's position 1. And then when we say print name, it will just print the entire array, Bob, Rita, Sue, Chie. But again, it'll print it with the square brackets. And with the commas. And again, it's not nicely formatted. It just shows us everything that's in the list. Have a look at the bottom here. This is interesting because we're going to have a common mistake. We're going to print the wrong index position from our element, and something strange is going to happen. So if I say print name 4, what's going to happen and why? Well, the computer is going to go, okay, 0, 1, 2, 3, 4. There is no 4. Oops. And it's going to crash the program. You're going to get a trace back. You're going to get an error message. So this is a common mistake because we look at it and we go, okay, there are 4 items in the list. I want to print out the last name, which is Chie. So I'll say print name 4. I forget that the counting starts at 0. So you're often going to accidentally try and print out one more item. And if you do that, it's going to cause an error. So get used to spotting that, checking your code and thinking, right, is that what I really mean? So in this case, it's not. What I really meant was 3 because that prints out the last item in the list. So be careful. So we can edit lists in different ways. Python has lots of nice inbuilt methods to make this easier for us. So let's take a look at some of them and just play around a little with changing the contents of a list and editing it. So take a look at this program here. And then over here, we've got the printout that shows you what happens when we run the program. Let's go through it and work out what's happening and why. So x equals 3596. So again, I've created my list. Got the square brackets there. Print x. Well, that's just going to print out the first line here. And again, 3596 prints it all out like that. Then I'm saying x1 equals 2. What's this going to do? Well, the computer's going to go along and go, okay, we got position 0, we got position 1, we got position 2, we got position 3. X position 1 now equals 2. So I'm going to get rid of the 5, and it's going to put a 2 in instead. And you can see that's exactly what happens when we do the next print statement. It prints 3296 because the 5 has been replaced by the 2. X dot append 10, X dot remove 6. So append means to add to the end. So for that line, the computer's going to go, okay, we've got the 3, we've got the 2, we've got the 9, we've got the 6. We need to add 10 to the end of this list. So it goes 3, 2, 9, 6, 10. The next line, x dot remove 6. Look through the list, remove this data item. So remove the 6 from your list. Then we print it again. And it's 3, 2, 9, 10. 10 because we've appended that to the end of the list. There is no 6 because we've removed it. Next one, x dot insert 215 print x. What does insert do? Well, it means go to this position in my list, add this data item. So go to position 2, add 15. So if you look, we've got 0, we've got 1, we've got 2. So this is index position 2, and I want to put a 15 in. Now this isn't going to delete the 9, it's just going to move it along and put a 15 in where it was and then move the 9 along. then move all the other data items along one position. Again, it's inserting it, it's not deleting anything. And you can see that when we do the final print statement, we've got the 3, we've got the 2, now we've got the 15 in position 2, the 9 is still there and the 10 are still there, they've just been shifted along 1. So that allows us to add an item, so insert allows us to add something into our list without replacing or deleting any of the previous content. When you do your exams, and when you have to do your algorithms and your pseudocode or your flowcharts, you're probably not going to be using things like append or remove. They're a little bit too nice and easy. But when you're programming away, when you're trying to solve tasks, these can make your life a lot easier. Let's look at array size as well. We often want to know what the size of an array is, how many items are in our list. So x equals 3596, print len, and then in brackets we've got the x. So what is this code going to do? Well, it's about the size. So if we run this, this is going to print 4 on screen because there are 4 items. 1, 2, 3, 4. 4 items in our list. So the len command just means length. Print the length of the list x, and that is 4. So there are 4 items. Remember, index position 0, 1, 2, and 3. But of course, that is a total of 4 items. It prints the length. So that's a very useful code to use, and we'll use it a lot as we do more programming with lists. Arrays, of course, are really good for storing lots of lists of data. So let's have a look here. We've got 2 lists. List 1 is the names of some people. List 2, or array 2, is just the ages of the same people. So Paul is 12, Philip is 15, Paula is 11, Philippa is 14 years old. And we want to print out all that data. So I'm going to say print name 0 is ages 0. What's that going to print? Well, we should guess it's going to go to position 0 on the first array and print out Paul. And then it's going to print out is. And then it's going to print out ages position 0, which is 12. So it should print Paul is 12. Print name 1 is age 1, should print Philip is 15. Then Paula is 11, Philippa is 14. Have a go, try this program, change the names and ages if you want, put the ages and names of your friends or whatever, your family members. Have a go, run it. Make sure you're comfortable using these index positions to find the different elements in your list/array. Okay, let's do a little bit more of a complicated activity. We're going to be given a list of 5 names and scores, and we want to print out all the names and scores that are above average. So let's have a look. We've got 2 lists here. We've got our scores, we've got our names. So if we want to calculate the average, we're going to do it in a really basic way. The average is score 0 plus score 1 plus score 2 plus score 3 plus score 4 divided by 5. So again, we're just going to go through and add this score, this score, this score, this score, and this score together. There's a better way to do that, but we'll look at that in the next lesson. Let's just keep it very simple. So we'll add all those together, divide by 5, because there are 5 items in the list. If you wanted to, you could use the len function and say len and then scores. But that's pretty easy. We can count. There are 5 items in the list, 1, 2, 3, 4, 5. So we can just divide it by 5. But if you're not sure how big your list is going to be, you could use len scores, which of course just returns how many items are in your list. Then we're going to say print the average is, and then what the average we've calculated is going to be. And the following results are above average. So we're going to look at each score, see if it's bigger than the average that we've just calculated. If it's true, we're going to print out the name and the score of that person. So remember, I don't know what the average is yet. Well, computer will calculate it, and then it'll print out all the names that are greater than the average. So if score 0 is greater than average, so it'll examine this, is 23 greater than the calculated average? If it's true, it's going to print out name 0, score 0. So obviously that's going to be 23 and Joe. if 23 is greater than the average. Let's have a look at the next line. Oh, skipping ahead a bit early. If score 1 is greater than average, what is score 1? Well, score 1 is going to be 11. That's Tom's score. So is 11 greater than the average? What's going to be the line that's missing here? How are we going to continue the program? Well, hopefully we can kind of work out. We're going to say print again. Oh, my handwriting's not very good on the screen just now. So we're going to say print. We're going to have some brackets. And what are we going to have here? Well, we know we're looking at the second set of data, so that's 11 and Tom. So that's going to be scores. Oh, not scores. We're going to use name first, just like the last one. We're going to say names, and we're going to say 1. And we're going to have a comma, and then we're going to say scores 1, because we're printing out position 1, which is the second item in our array, and that would print Tom and 11. Have a go. What can we do for the rest of the code? How can we get all this to print out? Have you done that? All working? Perfect. I'll bring up the results. Let's have a look. So you can see here, it's all fairly similar. If score 2 greater than average, print name 2 scores 2. If score 3 greater than average, print name 3 score 3, etc. Just be careful here that we're using ifs, not else ifs. Otherwise, it'd only print one set of data and then skip out. We want to look at each score one at a time. That's why we're going to use separate if statements for each one. Again, if you know a bit about programming, this isn't the most efficient way to do that, but we're going to look at making it more efficient by using loops in the next set of lessons. So we've got one-dimensional lists done. Let's look at something a bit more complicated. Let's look at what we call two-dimensional lists or two-dimensional arrays. And these are just lists of lists. Sounds a little bit complicated, listception. Think about a two-dimensional list or two-dimensional array as just a table with rows and columns. So here we go. This is a two-dimensional list. Each row is just a list. So we've got one list, two lists, three lists of numbers. But instead of having three different lists, we want to put them all together in one list with one variable name. Maybe these are test results or profits or scores or something. We want to put all this together in one list and store it as one variable. So we need to create a list that holds three other lists inside it. Hopefully I haven't blown your mind. It's not as difficult as it sounds. Let's take a look. So again, we've got the data, and here is my list of lists. So I'm going to call it results because maybe it's test results. So again, I'm going to start my list with a square bracket, and I'm going to close it with a square bracket at the end. And then inside it, I'm going to have 1, 2, 3 lists. Each list has its own set of square brackets to begin and end it. And I'm going to separate each list by using a comma. So take a moment, study that. You can see I've laid it out in such a way that it looks very similar to the actual data, doesn't it? So 78, 52, 45, 89, 97. Yeah, that's my first list. And then the second list, and then the third list. Again, making sure you put everything in the original list. So we've got 3 lists inside a list. Now, I don't have to lay it out like this. You see at the bottom here, you could just do it like that. The computer doesn't care about how you lay it out. But I find the bottom one a little bit more complicated to understand when I'm trying to think of how to access the data. I think laying it out like this makes it a lot easier to understand because it looks like the original data. That means I can think about how to access it and where the information is. But you can do it either way. The computer doesn't mind. It's whatever works for you. So how do we access each individual element within our two-dimensional list? Well, we need to think about rows and columns. And these are just numbered with positions just the same as a one-dimensional list. So the rows come first. We've got row 0, row 1, row 2. And then we've got the columns. Column 0, column 1, column 2, column 3, column 4. And we can just give the coordinates. We can say which row and which column, and the computer will go and find that data for us. So just a little bit of thinking, we should be okay. So have a look here. We're going to say print results, and then we're going to have the row and the column each in their own set of square brackets. It's easy to do something like this, 0, 0, but that's not how we lay it out in Python. We have 0, 0, each in their own nice set of square brackets. So the computer goes to row 0, column 0, and it would print 78. If I say print results 02, again, it goes to row 0, goes along to column 2, and it's going to print 45. Print results 21, well, go to row 2, go to column 1, and that's going to display 36. So again, try this out. Create the list, try accessing different positions in the list. Make sure you can kind of work out what's going to happen before you print it. It's very important. We've got to understand. We've got to give the row, then we give the column position. 0, 1, 2, 0, 1, 2, 3, 4. Don't get it mixed around. You're going to start accessing index positions that are outside of your array, and it's going to start crashing. So for example, if I wanted to print out this number, so I want to print 97, what do I need to print? Well, I need to print position 0, position 4, because it's row 0, column 4. But I might say 4 and then 0. And that's going to crash because it's going to go row 0, row 1, row 2. There is no row 4. It's going to crash. It's not going to understand you. So make sure you get the numbers the right way around. So that doesn't work. This does. So again, let's look at the code. We've got our list. We've got our print statements. What's going to print? Print results 2, 3. So what am I going to do? So remember, 0, 1, 2 is here. Position 3, 0, 1, 2, 3 should print 80. Print results 1, 1. Okay, so we go to row 1, column 1, 45, isn't it? Print results 1, 4. So again, we're going to go to row 1, which is here, and position 4, column 4. 0, 1, 2, 3, 4. Hopefully that's what's going to print. Again, be very careful with this. Make sure you understand it. Make sure you know how to access each individual element. That will make life a lot easier as your program becomes more complicated because you're going to use lots of lists. Lists are a really common data structure. Make sure you get this nailed really quickly. Okay, here is a two-dimensional list. If somebody enters a country, the program should print out the name of the capital city. So it's a two-dimensional list. I call it country city. It's two lists inside one list. List 1 is the countries: Italy, France, Great Britain, Germany. You see there we've got a comma. Then we've got a second list: Rome, Paris, London, Berlin. Again, I'm starting and finishing the list with the square brackets. Each individual list then has its own brackets around it. Don't forget your comma to separate the two. Again, you could put this on 1 line or 2 lines, whatever you like. But again, you need to think about what's position 2, what's position 1, which is the row, which is the column, things like that. So country chosen equals input. Please enter the country name. That's pretty easy. Somebody types in a country. It gets stored as country chosen. If country chosen equals country city 00, print the capital city is country city 10. What happens with this line? Well, if whatever was typed in is the same as country city 00. What is country city 00? Well, row 0, column 0 is Italy. It has the user typed in Italy. If they have, it says the capital city is country city 10. So remember, that's row 1, column 0, which is Rome. Makes sense. So if they type in Italy, it'll print Rome. Then the next line, if they type in France, it'll print out Paris. If the country chosen is the same as country city 01. So again, that is row 0, column 1, France. If it is, print the capital city is country city 11. So we're going to go to row 1, column 1, which is Paris. And you need to work out how to get it to print out London or Berlin if somebody types in Great Britain or Germany. So hopefully you can see the pattern here by looking at the numbers. Have a go at that. Let's take a look at our answer. So hopefully we've got something like this. So we're checking country city 02, and then we're going to print out country city 12. So that's Great Britain and London. And then country city 03, country city 13. So again, Germany and Berlin. So we know that's true. If you look at just that last line, country city 03, well, 03 is Germany. 13 is Berlin. Again, if you're not sure, try it, manipulate it, add some more countries and cities, add some more else ifs, try and get it working. Try and make sure you're clear in your own head how this works. Okay, I'm going to stop talking now. That's quite a lot about lists. You're going to do a lot of work with them. We'll do more practice in other lessons. Good luck with your Python programming, everyone. I'll see you next week.